MREs. How do they work? By Nick Taylor. First off, what are MREs? MREs stand for Meal Ready to Eat. These are self-contained, individual field rations designed to provide a full meal without requiring a kitchen, stove, or electricity. Each MRE includes a sealed entree pouch, side items like crackers or snacks, a drink mix, utensils, and most importantly, a flameless ration heater. MREs are specifically designed for situations where traditional cooking methods are not available. This includes military operations, disaster relief efforts, emergency response situations, and remote environments. The packaging is durable, waterproof, and built to last for long periods of time, which makes it ideal for crisis situations. What makes MREs unique is that they do not require refrigeration and can be heated safely using chemistry rather than fire. This makes them extremely practical in emergencies where safety, portability, and reliability are critical. Now moving on to its origin. MREs originated in the United States military. They were officially adopted by the U.S. Army in 1981 as a replacement for older ration systems. The goal was to create a lighter, more portable meal that did not require cooking equipment. They were developed by the U.S. Army Natick Soldier Research Center in Massachusetts. Later, the flameless ration heater was added in the early 1990s, allowing soldiers to heat meals without fire. This made MREs not only safer but more practical in field operations. Over time, this technology expanded beyond the military and is now also used in disaster relief and emergency situations. Now, what is the chemistry behind an MRE? Right here we have the big three. To start off, first is water activation. When a small amount of water is added to the heat pack, it dissolves the salt inside. This creates an electrolyte solution, which allows the ions to move freely. That movement allows electrons to flow, which activates the metals inside of the packet. Second is the magnesium reaction. Magnesium is a highly reactive metal, meaning it easily loses electrons. When magnesium comes into water, and forming magnesium hydroxide and hydrogen gas. And now third is the exothermic reaction. As the reaction occurs, new chemical bonds are formed, energy is released. Because this is an exothermic reaction, that released energy comes out as heat. This heat is then transferred to the food pouch, warming the meal safely and efficiently. Overall, the heater works by converting chemical energy stored in the magnesium into the thermal energy. Speeding up this process, magnesium produces the heat, but iron and salt are essential for making the reaction fast enough to be useful. Salt dissolves in water and creates the electrolyte solution. This allows electricity to flow and helps electrons move between the metals more easily. Without the salt, the reaction would happen much more slower. Iron works with magnesium to create a small electrochemical interaction, similar to a simple battery. Magnesium is more reactive than iron, so it gives up electrons more easily. The presence of iron helps draw those electrons away faster, increasing the rate of the reaction also. Together, iron and salt ensure that the reaction happens much quicker enough to generate significant heat within minutes. Now for the conductor. Magnesium is the key conductor and main reactant in the system. It is the metal responsible for producing the heat. Because magnesium easily loses electrons, it reacts rapidly with water once activated. During this reaction, energy stored in the chemical bonds is released. That energy then becomes the thermal energy that warms the food pouch. While iron and salt help speed up the process significantly, magnesium is the metal that actually generates the heat. Without magnesium, there would be no exothermic reaction and no warming of the meal. To keep it simple, magnesium makes the heat, iron and salt helps makes it faster. And now for my conclusion. It's certainly common good. In my demonstration, I used an MRE to show the exothermic reaction that happens between magnesium and salt water. When the magnesium came into contact with the salt water, the reaction began and the temperature increased. This temperature change shows how the heat was being produced. The heat came from the chemical energy stored in the magnesium being converted into thermal energy. This experiment showed what happened inside the real MRE heater. Magnesium reacts with the water, iron and salt help speed up that reaction. And then the energy is released as heat, heating up the food. warming the meal without the need for fire or electricity. And finally, what makes this powerful is not just the chemistry itself, but how it is applied. This simple chemical reaction allows soldiers, emergency responders, and disaster victims to safely heat their food in environments where electricity and kitchens are not available. MRE heaters demonstrate how science can serve the common good. They show how chemistry is not just something studied in a classroom, but something that can meet real human needs. Through this reaction, scientific knowledge is used to support safety, health, and human dignity during emergencies.